Hello everyone. So today we'll be solving Leetcode problem 4th of Biweekly contest 113. Pause the video, read the question and then I'll explain it. Okay. So in the question we are given a simple directed graph. Directed graph saying means that we have edges in the form of u to v. That means we can go from u to v and not to v to u. I mean, there may be a age from V to U, but right now we will have only ages from U to V. That means we can go from U to V and not vice versa. Okay. So, and yeah, one more thing, it has given that the graph would form a tree if edges were bidirectional. That means there are not going to be any any combination such as like UV and VU for the same pair of U and V. That means if every edge is bidirectional, then also it will form a tree. That means it is not going to have any loops. Okay, that means if we can select any node, let's say if it's a tree, let's say if just a tree, what it is trying to say that there will be no circles, no circle in the sense that there will be no cycle, no cycle. That means if we'll start, let's say if we consider this as the root, we can start from here and we can traverse to everywhere. Okay, and there will be always a unique path. That's why it's a tree. Okay, so that's one thing. This will be used. That's why I've explained this right now. Okay, so now what the question is saying that first of all it's defining edge reversal as, let's say if there is an edge from u to v, then if we reverse it then the edge will become v to u. Okay, now what we need to do is for every particular node I, how many edges needs to be reversed such that we can start from the node I and can reach every other node. For example, let's say if in this given example, if we are at 1, then we should reverse how many edges such that we can go to every node. Like from 1, we can simply go to 3 without reversing any nodes, sorry, any edge. From 1 to 2, we need to reverse this particular edge, so we'll be reversing 1, and like 1 to 0 we can go directly, if we reverse this edge then we can go from 1 to 2 and then 2 to 0 as well. So in total we'll have to reverse this just one node, so for the sorry one edge. So for this node 1 we need to reverse one edge. Similarly, if we'll check for 0, we need to reverse this edge and then we will be all good to go. Okay, and if we'll check for 3, first of all we need to reverse this edge and then we need to reverse this edge, then we will be able to visit all the nodes. So the question is, for each particular node we need to return how many edges needs to be reversed for that particular node. Okay, so basically we need to return a array where array of I will denote that for node I we need to reverse array of I edges. Okay, I hope the question would be clear. Now, how are we going to approach it? So the very first thing we should notice is it's a tree if it's a bidirectional. That means if I am at root, then I can traverse everywhere. Okay, so let's say if if we consider any one root, like if it's a tree, we know that we can consider any node as the root. So if we consider this as the root and then we try to go from here to every node. So what I'm trying to say, like here we went to here, then here, and also we can go from here, then we come here, then we come here, then we come here. And let's say for this we know that three edges needs to be reversed. Okay, let's say for the time being we needed to reverse three edges so that we can traverse from this route to every other node. Okay, what I am saying is, I will repeat once. So I am saying that if this is the tree and we want to traverse every node. Okay, we want to traverse every node, so from the root we want to traverse every node, here and here. If we want to traverse every node, we need to reverse three edges. Okay, we need to reverse three edges. So for the root, the array we are going to return for the root, it will have three. Okay, that's one thing. Now, now let's say if somehow I know if somehow I know that for this particular node, I need to reverse one edge to reach to this root. Okay, what I am saying is, I'll just change the color of the pen so that it's more visible. So what I'm saying that from this particular node, we need to reverse exactly one edge. We need to reverse one edge to reach from this node to this. Okay. Now what I'm saying is, so let's say in total, in total, in total there were, like right now here we are considering three, right? So let's say we needed to reverse total reversed edge, total reverse edges, or let's denote it as m. So in total, if we started from this root, we needed to reverse m edges. Okay. Now what I'm saying is, for this node, if we start from this node, okay, we need to reverse one edge to reach here. What I'm saying is, let's say for any particular node, if we want to go to root, we need to reverse exactly one edge. Okay, we need to reverse one edge. Now, so what I am saying is, if we are at here, if we are at node, and then we went to this root, then in the in between there will be so many nodes, but in total we have to reverse just one node, sorry, one edge. We need to reverse just one edge, and then once if we are in this on this route, then we know that we can traverse all the edges, sorry, we can traverse all the other nodes using m reversals. That's what we have already assumed right over here, saying that we need to, if we will start from this root, we need total m edges to be reversed. Okay, so if I reach to root, then I will need m edges to m edges needs to be reversed. Now the only thing I need to care about is this path. So this is the path we need to be little careful, because it might happen that from root, while we're traversing to this node, we have reversed few edges, but they don't need to be reversed if we go from here to here. So what I said that if we move to node to root, we needed to reverse one edge, and let's say the total number of edges between node and root, that is depth of node, we can consider that as depth. So depth of node is d. That means there were total d edges from root, in between root and node. And if we are going from root to node, then we need to reverse one edge. That means if we come from root to node, if we come from root to node, that means we need to traverse, sorry, we need to reverse d minus 1 edges, because total there are d edges, and depth will be d, sorry, depth of node will represent the number of edges from the root. Okay, so if we are going from node to root, then we need to reverse one edge. That means if we'll come from root to node, then we'll have to reverse d minus 1 edge. Okay, I hope that will be clear. So if we are at root, we know total m edges needs to be reversed. And if we are at, so let's say if we are at root, then we need to reverse m edges. And for going to node to root, we have to reverse one edge in this question, or let's say k. Let's replace this with k. So we need to reverse kh, and that means, and we know that depth of node is nothing, basically the edges. So let's say I'll just give one example. So for this root, depth is 0. There is one edge between this node from the root to here, so depth will be 1. For this as well, from here to here, depth will be 2. Here depth will be 3, and this, for this depth will be 1. So basically depth is nothing but the number of edges from the root to that particular node. And now the depth of node is d. That means the no edges that needs to be reversed between node to root to node will be equal to d minus k. Okay, so if we know that we have now what we have, so we have this tree, any particular tree, let's say this is the tree we have, and if we are at root, we know that we need to reverse m edges. If we are at, let's say this is the particular node, so for from this node to reach this root we need to reverse k edges. Okay, so let's consider like what will be the total edges. So if we are at root we need to reverse m edges, and if we are at this node then to reach root we need to reverse k edges. But but so what needs to be done is, when we would have counting like this particular m, that is total number of edges to be reversed if we start traversing from no root to any all the particular nodes, then we have counted all the edges that needs to be reversed for this one, and now those does not need to be reversed, and we know that the number of nodes that is getting reversed if we move from root to node is d minus k. Okay, so what we need to do is, from this total value we need to subtract this d minus k value. Okay, so I hope this will be clear. I am repeating once again. So what I am saying is, if we know that, if let's say let's take a sample tree, what I am saying, this is the root and this is one particular node. Solution is very simple. You just need to understand the intuition behind it. Okay, so this is the root and this is the node. Now what I'm saying, that if I will start from root and will traverse everywhere, then I need to reverse exactly m edges. Okay, m edges needs to be reversed. Now we know that depth of node depth of node is nothing between the but the number of edges between root and node. Depth of node is d. Okay, and we also know that if we are at root and if we want to reach node, then we need to reverse, let's say reverse of node. Okay, reverse of node is, let's say, a, what is reverse denoting over here, that how many edges needed to be reversed if we are moving from root to node, that is equal to a. That means if we'll move from node to root, that means if we move to node, what I'm saying is, listen carefully, if we are moving from node to root, that means the number of edges that needs to be reversed is total edges minus the edges that we have reversed if we are coming from root to node. Okay, so let's say if there are some this many edges. Okay, so if we are moving from here, let's say it was root and it is node. So right now if we will move from root to node, then we will have to, so first of all let's say what is the total count of or the depth of the node, 4, because there are 4 edges. Now if we will move from root to node, then we will have to reverse just this one particular node, so sorry, one particular edge, and then a will be 1 over here. So if we will move from node to then root, then what will be the edges that needs to be reversed? These all 3, and that we can calculate from d minus a, that is equals to 4 minus 1, that is equals to 3. So that's what I am doing over here. So let's say if I go from this node to root, so how many edges I need to change? The total depth, or like the depth of node d minus the value of reverse of node. Okay, and what is the reverse of node? That how many edges are reversed if we are coming from root to that particular node. Okay, how we are going to find it, we'll see in the solution. Okay, but let's consider that we have that. Okay, so we have d minus a. Now we, if we are at root, we know that we need m edges to be reversed, but we also need to subtract the edges that we are counting from moving from root to node, and that is reverse of node. Yeah, because in the reverse itself we are storing for a particular node how many edges are reversed. So right now if we are at node and then we went to root, then we don't need to consider all the edges that are reversed here, because that we are already considering here d minus a. So we just need to subtract m minus whatever the value of reverse of node over will be over here. Okay, so that we can subtract is, let's say it is represented over a, right? So we can simply write it as a. Okay, I hope this solution would be clear with you. Now how can we implement this? How can we implement this? So now if we have root and then we need to store the depth of each node, right? So that means, okay, name is a bit confusing that it should feels like there should be depth first search, but it should be breadth first search, right? Because we need to see on each level what is the depth. Okay, so we can simply do a, I mean, we can do DFS as well, but we'll go with BFS here. So we'll have simple, let's say if our root is 0. So we can simply have our root 0. I'll walk through the code that will give you better understanding what I'm trying to do is. So first of all, yeah, we created our, yeah, there was one thing that we created tree as if it was undirected. Okay, so first of all, I created tree if it was undirected, and then I have also kept the count of the directed node edges. So for any particular I, if there is a edge between u and v, then I have made a set. Okay, set and then set directed edges, and for directed edges of u, I have inserted v into that. So basically, it will be a set of vectors, sorry, a vector of sets. Okay, a vector of sets, and for each particular node, we are storing to which nodes it is pointing to. So if let's say it's 0 and it's pointing to 1, 2, so for 0, we'll be storing 1 and 2. Why we are doing this? We are doing this so that in future we can check if the node needs to be reversed. Let's say like u was the parent, and if we move to child, and if child is not present in the set of u, that means this node needs to be reversed. Okay, that's why we are storing the directed edges as well. Okay, so now initially we are just marking depth as -1. We will be also using this as a visited array, and we are having a array reverse that will store the number of edges that is reversed if we have traversed from root to that particular node. Okay, and we have considered 0 as our root, so depth for 0 will be 0, and we'll push the 0 into the queue. And we also have one variable total reverse to calculate or to keep the count of how many edges needs to be reversed if we start from this particular root, that is 0. Okay, now this is simple BFS search. While queue is not empty, we have popped the first element, then we have iterated over the children, and if depth is equals to -1, that means it is not visited and we should visit it. Then the depth of v will be depth of u plus 1. Okay, and now depth has increased, but we need to check if this edge was the edge between this u, the current u we have, and this the child v, as this edge needs to be reversed. So we know that if there will be edge between u to v or from u to v, then u must contain this v. So we'll check if directed edge dot count v. If it's 0, then we will sorry, yeah, if it's 0, that means we need to increase the reversed value of this particular v by whatever we have for u plus 1, because this edge needs to be reversed. So reversed of v will be reversed of u plus 1. Similarly, total reverse will be increased by 1. Else we are not reversing any edge over here and traversing from u to v, then reversed of v will be same as reversed of u. Then we can simply push the v into our queue. Okay, so after this while loop, what we'll have one depth array. Okay, I'll explain again. So what we'll have one depth array, and what it will represent from the particular root, that is 0. It will represent the number of edges between 0 and any particular node I. So if we'll see depth of I. That means it is saying the number of edges between root, that is 0, and I. Okay. And what is reversed of I? That is saying that if we move from 0 to I, then how many edges needs to be reversed? That is stored in reversed I. Okay. Now, if now, yeah, let's coming to here. So for each particular node, I equals to 0. So for any node, let's say what, again I am repeating the same thing, that if we know that traversed total reversed edges, that is equals to m, let's say m. Okay. Now for any particular I, we know that for any particular I, we know that if we want to go from that particular I to root, then we'll have to subtract reverse from the depth. That's what I am saying now. So that's what we discussed. That, so let's say this is the depth. This is, sorry for bad handwriting or bad drawing, I would say. So this is the depth, let's say, and we reverse, let's say, this only one edge. That means if we, yeah, the reverse have the count if we move from root to this particular node. But what we need actually is if we are at this node and want to go to the root. So this will be just total number of edges minus the ones we reversed while going from 0 to, sorry, root to node, because they are already aligned with our direction. So we just need to turn the remaining edges. So that we done here. Now we know that if we are at root now, we take total reversed edges to be reversed. Okay, we need total reversed edges to be reversed. Now as we have already completed this particular path for a particular node, so like for any particular node, whatever the path between this particular root and this particular node we have followed, we have already taken into the consideration the number of edges we need to reverse. So out of all the total edges, we need to subtract the edges that we have added, because in total edges we have the edges if we move from this root to particular node, but we are not going into this direction, so we need to subtract those edges. And we know that that count is stored in reverse, so we can subtract the reverse of I from total reverse, and this sum will be answer for particular I. Okay, and finally we can return this result. Okay, let's submit the solution and check if it's correct. Yeah, it's AC solution. I hope the solution is clear, and if you have any doubts, please ask in the comment section. Thank you.